Hello everyone, this is Srikanth, working as assistant professor in electrical department. Here we have overview and some definition terminology on electrical circuit analysis. Coming to analysis, so any circuit, I need to find out the unknown values like voltage, current, power or equivalent resistors. So for that, I need to use different analysis and different methods and different logic. So all those things we will cover in this video. So here we have some topics: source transformation. That means we have the current source as well as voltage source. We can transfer those sources and Kirchhoff's laws. So in intermediate also we have the Kirchhoff's laws and equivalent resistance, equivalent capacitance, equivalent inductance, and star to delta, delta to star transformation. You can. So if you have star circuit, you can convert into delta circuit. Otherwise, you have the delta circuit, you can convert into star circuit. And we have like mesh analysis, nodal analysis, and inspection method, as well as supermesh, supernode analysis. So here I have voltage division rule, current division rule, and source transformation. So coming to voltage division rule, when we have like closed circuit, when you have a closed circuit, I need to know what is the voltage drop. So I have a closed circuit and connected n number of resistors. Then I need to find out the resistor voltage drops. So using voltage division rule. So we have the logic. You can use that logic or you can use that formula. So here I have circuit. Just observe. So 1, 2, 3 resistors I have. Suppose my voltage, source voltage, and I know the R1 value, I know the R2 value, I know the R3 value. I need to find out VR1, VR2 and VR3. Okay, so I know the voltage values. So I know the resistors and source voltage value. I need to find out the R1 value. So for that, very simple. So that formula is not only formula, that is on logic. Okay, so these are connected in one loop. So we have some I current. So what is the I formula here? So voltage by resistor. What is the voltage? Source voltage. What is the resistor? R1 plus R2 plus R3. 3 are in series. So R1 plus R2 plus R3. This is your I. Suppose I want to find out the voltage drop here. That voltage drop is nothing but I into R. So what is I here? That is Vs by R1 plus R2 plus R3 into your R1. It's very simple. So suppose I want to find out the R2 voltage drop. So R2 voltage drop means I into your R2. But here I is source voltage by your total resistor. So 3 resistors connected in series and they are in loop. So we have the I value in closed loop V by R. R is here R1 plus R2 plus R3. So Vs by R1 plus R2 plus R3. That is R total into your resistor R2 resistor. That is a voltage drop across the V2. If you observe the formula here, Vs by R total. So how many resistors we have? The total into which resistor voltage you want to find out. That resistor value. That's it. Coming to current division rule. So voltage division rule, series and they are in one loop. Coming to current division rule, parallel. So voltage source. So not voltage source here. When you are coming to parallel means current source parallel with n number of resistors. So here we have the voltage source. If I know the current value, source current value, I can find out the n number of branches currents. So here we have the R1 value, R2 value. I know the source current value. Then I can find out the R1 value, R2 value, IR1 value, IR2 value, or any IR3, IR4, n number of. So the formula is source current. So which current we have? That source current into opposite resistor. Suppose I want to find out the IR1 value. So IR1 opposite resistor is R2. So this branch current I need to find out. This branch current opposite resistor is R2. If suppose. So my question is, here I have some current source and 1, 2 and 3 and 4. So 4 resistors connected. I want to find out the first branch current. So I want to find out the first branch current means what is the opposite resistor. Suppose it's the R1, R2, R3, R4. So what is the opposite resistor there? So these three are opposite. So what is the three are opposite means? What is the total there? So three are connected in parallel. So you need to use the parallel formula and find out the value of that equivalent value. So one resistor value. That is the opposite resistor of this R1 value. So I will find out the R1 here. For this opposite resistor is R2. So R2 by your total resistor. Again R1 plus R2. Here again total resistor. So here we have like R equivalent. So R1 equal to Is into opposite resistor. That is R equivalent value. For this three resistor equivalent value and R equivalent plus your R1 value. That is the formula for current division. Coming to source transformation. So if I have the voltage source series with resistor, voltage source series with resistor, I can convert to current source parallel with same resistor. So resistor value is as it is. So resistor value is as it is. So I have voltage source series with one resistor can convert into current source parallel with same resistor. So resistor value is same. Okay, what is the current value? So current value is, it's very simple from Ohm's law. So if I want the I value is V by R. That is a simple formula. If suppose I have a current source parallel with resistor, I can convert into voltage source series with same resistor. So what is the voltage value? Same. V equal to I into R. V equal to I into R. It's very simple, but different analysis. You can use this source transformation and get the answers in easy way. Okay. So this is about the basics rules: current division rule, voltage rule, and source transformation. And we are moving to Kirchhoff's laws. So Kirchhoff's laws is very important to solve n number of analysis. So coming to Kirchhoff's law, we have two laws. That is, first law is your current law and second law is your voltage law. So current law means at particular node, incoming currents are equal to outgoing currents, or summation of all currents. So all currents, incoming and outgoing, is equal to 0. So both are same. You can use any one method. So at a particular junction, so you need to know the which junction you want. Okay, a particular point. So which point you want? A particular node, which node you require. So a particular node, the summation of all currents equal to 0. Coming to voltage, in a closed loop, the voltage drops. All voltage drops equal to summation of all voltage drop equal to 0. Okay, otherwise supply, which supply voltage is equal to drops voltage. Summation of all drops voltage. Okay, here coming to circuit. Suppose I want, this is my node. This is my node means not this particular node. So here and here both are same. So coming to this node and this node. So between we don't have any element means both are single node only. Suppose for this condition here we have only one node. So this is also only one node. And coming to suppose not there I want here. So at particular point. So at particular point means this is also that branch. Okay, this is only one branch. Here one branch. Here one branch. So 3 branches. Here also we have 1, 2, 3 branches. Coming to here, so 1, 2, 3, 4, 5 branches. Okay, so just observe. Suppose you are considering one particular node means for that node how many branches are connected and what is the branch currents. How many branches are connected and what is the branch currents. Clear? So coming to this circuit, here has a 5 branches, 1, 2, 3, 4, 5 branches. So what are the 5 branches current? Here we have like a IR1, IR2, IR3, IR4, IR5 and IR6. So IR5 we have, so 5 branches, 5 currents. Now I am to find out the Kirchhoff's current law. So Kirchhoff's current law equation. Now incoming currents are equal to outgoing currents. So how many incomings do we have? So IR1 is incoming and IR4 is incoming. Remaining 2, 3, 5 is outgoing. So 1 and 4 are plus, remaining are minus. Equal to 0. Incoming are plus, outgoing are minus. Or summation of all currents equal to 0. Otherwise incoming currents equal to outgoing currents. Okay, this is your Kirchhoff's current law. Coming to voltage law in a closed loop. So this is a closed loop. Summation of voltages equal to 0. So here we have like a negative, positive, so minus Vs, and here voltage drop is suppose VR1, here VR2 and VR3. So minus Vs equal to Vr1, Vr2, Vr3 equal to 0. Otherwise, you can write like a Vs equal to Vr1 plus Vr2 plus Vr3 also. You can use any one method. Okay, so this is about the Kirchhoff's voltage law and current law. And coming to, so don't forget those logics. Okay, so coming analysis, how many analysis we have? For each analysis, we need to use these 5. So Kirchhoff's law, like current law and voltage law, and current division rule, voltage division rule, as well as source transformation. If you know, like, if these 5 logics will get remaining analysis, like Nodal analysis, mesh analysis, or inspection method, so anyone. Okay, now coming to, and series parallel also. So coming to series parallel equivalent resistance, we require the formulas. So we have resistor, inductor, and capacitor. So 3 passive elements we have, 3 loads, RLC loads we have. Now for this resistive load, what is the current and voltage formulas? So voltage equal to I into R from Ohm's law, and I equal to V by R. So these are the general formula. And coming to inductor, V equal to L di by dt, and I equal to 1 by L integral V dt. So remember, the inductor store the energy in form of current. So small current, that is di by dt. So V equal to I into R, same formula, but here I is di by dt. And if substitute like both side integral, we will get like I equal to 1 by L di by dt. And capacitor, for capacitor, it stores the energy in form of voltage. So I equal to C dV by dt. Okay, now apply both side integral, we will get like V equal to 1 by C integral I dt. So these are the formulas, general formulas which you know, like in from Ohm's law. For equivalent resistors, we require these formulas as well as Kirchhoff formulas. Okay, now we'll check it now for equivalent resistor, inductor, and capacitor formulas. Yeah, here we have like series as well as parallel. For series circuit and parallel circuit. So when I start my BTech, starting in first semester, there I have small doubt, which is a series, which is a parallel. So 2 resistors in series means, I will say like the both are in series. Okay, and both are in parallel means, how can I find out both are in parallel? In big circuit we have, so in that which is a series, which is a parallel means somewhat difficult to find out. But here I have a small logic to find out those series and parallel. Check it now. Suppose resistor 1 is the first point and this is the second point. Okay, and resistor 2 first point and second point. So if you observe the points, both points connected one place, and there is no current division here. So there is no current division another path with another path. So here the current is same. In this point current is same. There is no current division. So if you don't have any current division and they are connected particular point, which point they connected, there is no current division. So which current I have at R1, same current at R2. That means both are in series. Coming to parallel, so here we have 2 points. So point 1 and point 2. So at point 1, the both ends. So first end is connected to one point and second end connected to one more point. And we don't have any other elements between them. Okay, in this point we don't have any other elements. So first point, second point, second point. And the voltage for both resistor is same. Here when we have the series, the currents are same. In series we have current is same. In parallel we have voltage. So at R1 which voltage we have, at R2 also which voltage we have. So both voltages are same. So this is the logic to remember which are the parallel, which are the series. If you want to remember means these are some logic. Okay, and coming to series and parallel. So when we have the series resistors, we have the formula is R1 plus R2. So simple logic, just apply the voltage. Okay, and in a closed loop, we have only one current. We have only one loop, only one current. So here voltage drop, here voltage drop equal to this voltage, Kirchhoff's voltage law. Using Kirchhoff's voltage law, just find out the values. So here Vs is equal to VR1 plus VR2. Am I right? Now Vs you can write like I into R, and VR1 you can write like I into R1 plus I into R2. So in a closed loop, which I we have here? Same I, here also same I. Closed loop, only one loop we have, so only one current. So the currents are cancelled. So R equal to R1 plus R2. Simple logic. Same thing parallel. Parallel we need to compare with currents. So here incoming current I is equal to I1 plus I2. So I is equal to I1 plus I2. So for this I we have V by R. Same voltage R1, same voltage R2. So V by R1 plus V by R2. That is your IR1, IR2. Now V gets cancelled. 1 by R equal to 1 by R1 plus 1 by R2. So simple logic. Okay, so there is no like any big equations. Simple logic, and you can remember those formulas. And this is about series and parallel. So when we have the series resistor, the value is R1 plus R2. When you have the parallel resistor, we have 1 by R equal and equal to. So here only 2 we have, means just write this formula better. R equal and equal to R1 into R2 by R1 plus R2. Okay, when we have the 2 resistors, you can use this formula better. Why means, suppose I have 2 resistors parallel. So suppose here 2 and 3. So 2 and 3 I have. So in general, we'll do like this. So 1 by 2 plus 1 by 3. So 1 by 2 plus 1 by 3. My value is 5 by 6. Am I right? So 1 by 2 plus 1 by 3, the value is 5 by 6 for R equivalent. Am I right? That is the answer? No, it's wrong. It's wrong. Why means, here 1 by R equal to 1 by R1 plus 1 by R2. So 1 by R equal to 1 by 2 plus 1 by 3. So your answer, our 1 by R equal to 5 by 6. But your R equal to 6 by 5. Not 5 by 6. R equal to 6 by 5. Here, this is 1 by R equivalent, not R equivalent. So when you are doing, if you know the formula, just apply step by step. So in general, we are in exam, formula is right, procedure also is right, but coming to end of your answer, 1 by R equivalent to 5 by 6. But they miss 1 by R1, they write only R equivalent. So they miss the 1 by value. Okay, so some disturbance in your exams. When I check like answer papers in your exams, so I saw this type of errors. Coming to inductor also same. For resistor and inductors, we have the same formula. So 1 by L equivalent for series L1 and L2, L equivalent to L1 plus L2, and parallel 1 by L equivalent to 1 by L1 plus 1 by L2. Coming to capacitor, it's like reverse. Capacitor, it's reverse. Why this reverse means? Suppose I want to apply the voltage here. I want to apply the voltage. Some voltage. Okay. Then V1. So VC1. So otherwise you know it like V1 and V2. So Vs equal to V1 plus V2. Coming to V of capacitor. What is the V of capacitor? So capacitor voltage is 1 by C integral I dt. Same. So current, which current we have here? Same current. So 1 by C1 integral I dt plus 1 by C2 integral I dt. So I dt gets cancelled. We have 1 by C equal to 1 by C1 plus 1 by C2. Again, simple one only, but think when you are writing the formula. So maximum in exam, suppose 2 capacitor values, here 2 and here 3, then maximum people write like that only, 2 plus 3. So that is wrong. So when capacitor in series, then the formula is 1 by C equivalent or C equivalent equal to C1 into C2 by C1 plus C2. This is a formula for when two capacitor in series. Coming to parallel, then we can add both values. Okay, so this is about series and parallel of resistor, inductor, capacitor. So don't forget those formulas. For series means R1 plus R2 and parallel means 1 by R equivalent equal to 1 by R1 plus 1 by R2, so on. So how many we have? So 1 by R3, 1 by R4. So, okay, for inductor also we have the same as your resistor. Series means you can add, parallel means that is 1 by equivalent equal to. Coming to capacitor, it's reverse of resistor and inductor. So that is 1 by, when you have the series capacitor, that is 1 by C equivalent equal to 1 by C1 plus 1 by C2. Okay, these are some formulas on series and parallel. Coming to, we have one more topic, that is like star to delta and delta to star topic. It's very, very important when you are solving big circuits. So in your circuit, I will find out the equivalent value, or I will find out the current values, I will find out the voltage values. So for that circuit, somewhat difficult. Then you can convert that circuit to simple circuits using star to delta and delta to star. So if suppose in my circuit, I don't have any series parallel values. So I don't have any series, I don't have any parallel resistors or inductors. Then I need to convert those circuits to your series parallel. So I will show you one circuit here. Voltage source, resistor, between I have one resistor. Okay, so simple circuits, small circuit only compared to others. So 1, 2, 3, 4, 5, 6 resistors I have. So if you observe this circuit, you have any series and parallel. So we don't have any series and parallel. For this circuit, we don't have any series and parallel. So for this, we have formulas. We can convert which resistors we have here, star position, which resistor in having delta position. You can convert both if you want to convert delta to star or star to delta using these formulas. We will check it now. So for this resistor, if you want to convert in delta or star, first mention the nodes. Okay, so suppose this is A node. So between 4, I want to convert like a 4, 5, 6. So 4, 5, 6, I want to convert into and different manner. First, I will check it. Those are in connected in that delta connection or star connection. Okay, A and here B, and here I can select C. So I have 3 nodes. In between 3 nodes, the 3 resistors connected in delta position. C, A, B, and C. 4 resistor, 6 resistor, and 5 ohm resistor. So they are connected in delta position. If suppose you want to convert it into star position, so same place, guys, remember at same place we need to convert those to star values. So A, B, C. So don't confuse, just mark the node values between. I want to convert the values. So suppose X, Y, Z, some your name, which name you want. So I have X, Y, Z values. Now check your circuit here. So same circuit. If you observe clearly, so voltage source and 1 ohm resistor as it is, 2 ohm resistor as it is, 3 ohm resistor as it is. Coming to A node and B node and C node. So A, B, C nodes I have. Here actually we are having delta position. Now I converted into star. Now in between A and C I have here. Coming to here I have A and C. I have which resistors I have? Z resistor, so X resistor and Z resistor. So A and C. A and C I have X resistor and Z resistor, and B and Z resistor, B and you can say here B and here C. B and C I have one more resistor. Otherwise, consider one point between those resistors. Here, suppose O. So here O. So A to O I have X, and B to O I have Y, and O to Z I have O to C I have Z. And last, this is a closing part. Okay, so which circuit do we have in previous case? Now which circuit we have? Now if you observe 1, 2, 3 and here X, Y, Z. So values, which values will get from using formulas. Now 2 and which X value, both are in series, we will get like one resistor. Here 3 and Y, both are in series, we will get like one resistor. Then which value we have, suppose A value and B value, both are in series, both are in parallel, we will get like C value. This C value series with Z as well as 1. You can solve the equation in single loop. Okay, so main thing is we need to know which is the star connection, which is the delta connection. So which resistor we are using, which point. Okay, again I am repeating why means it's very important to find out the nodes values. So same circuit. Now I want, so I have, so same circuit guys. Here I have the values. Some values I have like a 1, 2, 3, 4, 5, 6. Okay. Now I want to convert the circuit. So I don't have any series and parallel. First of all, I don't have any series and parallel for this circuit. So I want to convert in different manner. I want to convert into different manner means, so I don't have series and parallel. So I will go to star to delta or delta to star. Just observe now. Here 1 point, here 1 point, and these 3 are 1 point. Okay. Suppose here A, B, C. These 3 are connected in delta, so I will convert into star. So between 1, 2, and 3. Same place. At same place we need to convert. Okay. Now suppose, so this total circuit, your total circuit will get like resistor as it is, 2 ohms as it is, and 3 ohms is as it is. But A, B and C, between O we have, so A and O have a resistor, B and O have a resistor, C and O have a resistor. Series. Now these two are series, these two are series. Suppose I want to find out that for same circuit, okay, for same circuit, guys, just think before which node you want to take. Okay, so here I want to convert. Now delta to star already are done. Now I want to convert star to delta. So in this circuit, do we have any delta connections? Yes, we have delta connection. We convert into star. Now for this circuit, do we have any star connections? Yes, we have a star also. We can convert into delta and we will get the answer. How will convert in delta? Which is the star here? So any 3, just consider any 3 and check the nodes. Suppose A node and B node and C node and D node. Otherwise A, B, C and this is a O. In middle O. So 3 are connected 1 point. So 3 resistor connected 1 point. So middle is your O. A, B, C, 3 resistor. So same 1, 2, 3, 4, 5. Now this 2, 4, 5 is star connection. See, observe. So A point, B point, C point and O. So 3 are connected on point. 3 are connected on point means, so these 3 resistor having the star connection. Now convert into delta. Delta connection. Find out these values. So X, Y, Z values. Now these two are parallel. Then parallel with Y. So both are in series, then parallel to Y and series with 1 row. So any method you can use, but we need to know the which are the series, which are the parallel. So this circuit will get like when you are converting to star to delta, your circuit is here B and C and E. A. So ABC we have. So B and B and A. So B and A I have the resistor, and B and C I have 3 ohm resistor. So B and C I have 3 ohm resistor, and again B and C we are converting to delta. So B and C we have one more resistor. B and C we have one more resistor, and here C and A when I am coming to delta to star, C and A I have one resistor. C and A I have one resistor. Again C and A I have one more resistor. C and A I have one more resistor. So these are the, suppose X, Y, Z. When I am converting to delta to star, these are my values, and 3 and 6 is as is in previous cases. Now these two are in parallel, these two are in parallel, then series, then parallel with Z, then series with one more. Guys, it's very very simple. If you know the which place you are converting, it's delta to star or star to delta. Okay, coming to formulas. So if you know the logic, but for that I require the formulas also. So if you don't know the formula, we can't get the answer. So for this also has some logic to remember those star to delta, delta to star formulas. Coming to our circuits, so these are delta, orange line is delta and green line is your star. Now I have the delta values. Here RA, RB, RC is my delta values. I know the delta values. I need to find out the R1, R2, R3 values. So for that RA, I want RA means, so RA, what is the opposite resistors? That is, so R1 opposite resistor is RA, RB. So your formula is very simple. RA, RB by RA plus RB plus RC. If you want like R2 value, if you want to R2 value means RC as well as RA, both are in opposite for R2. So your formula is RA, RC by RA plus RB plus RC. When we have the delta values for star, these are the formulas. So if you want the R3 value means opposite resistors, so B and C. So B and C into those one. Okay. If suppose I have like star values R1, R2, R3 values. When I know the star values, I want to find out the RA value. So RA opposite resistor. Which is the RA opposite means in delta. In delta I have the RA value opposite. So in star, which value we have? So RA opposite is R3. So RA opposite is R3. So R3 is in division position. And in denominator, we have the R3 value. In division position, we have RA into RB. So that means R1 into R2 plus R2 into R3 plus R3 into R4 by your R3 value. Coming to star to delta. So if I know the delta values, I can find out the star values. If I know the star values, I need to find out the delta values also. So for this I have logic also. Just check it now. So I know the R1, R2, R3 values. In delta position we have RA, RB, RC. So consider like one loop. So they are connected in series. Series means this is the formula. So series we have the R1. So we know the delta to star. Now coming to star to delta. So we can't say which is the series, which is the parallel. So remember like that. So which is the series, which is the parallel, we don't know. Then use the formula R1 into R2, R2 into R3, R3 into R4. So R3 into R1. So R1 into R2 plus R2 into R3 plus R3 into R1 by, so which resistor we want means, suppose I want RA value. RA means RA opposite. That is R3. Suppose I want like RC value. RC opposite is R1. Same R1 into R2 plus R2 into R3 plus R3 into R1 by R1. Just think. So which formula you need to use? So I know the both formulas, but which formula for applicable for which star to delta, delta to star. So for that, remember like this. So delta having delta. So delta values having in one loop. Suppose one loop means they are series. Series means in division position you say like R1 plus R2 plus R3. So like RA plus RB, RC. Delta values series, but star values not in series. So we have R1 into R2, R2 into R3, R3 into R1 by opposite resistor. So when you are the delta to star means I want the R1 value means this is the delta values series. Okay. Suppose I want like delta values, then star values in So multiple positions. So not in series, not in parallel. Just logic. Okay. So this is about star to delta and delta to star. Coming to mesh analysis. So it's very simple and very important. It's very simple. So why simple means if you know the Kirchhoff's voltage law. So Kirchhoff's voltage law, it's very simple. In a closed loop, the sum of voltage is equal to 0. So we need to know the how many loops we have. First identify the number of loops. Then give the current directions. Give the current direction, any direction. Depending upon your direction, we'll get the answer. But at end, we have the result is same. So this answer plus or minus. Plus means we'll get the same direction. Minus means we have the reverse direction. That's it. But answer, which result we have, that result is same. Okay. So current direction. So don't worry about the current directions. You can use any direction. But same direction, we take the values. And coming to third step, that is apply the Kirchhoff's voltage law. So particular branch, we need to know the voltage drops and that voltage, the sum of voltage in a closed loop equal to 0. Use that logic and find out the equation. Then the fourth step is we need to solve those equations. Suppose two loops I have. So two loops means we'll get like two unknown values, that is current values, and you can find out the I1, I2 values using two equations. Then last, where you want to unknown values like voltage, power, or any other values, you can find out using those current values. Okay, so why this mesh analysis means n number of loops I have. So I have the n number of loops. So n number of loops currents I require means using mesh analysis, it's very simple. So we have loop currents, branch currents. You can find out the branch currents, loop currents in this mesh analysis. We'll check it now. So here I have small circuit using two loops. So two loops means first step we need to identify the number of loops. So loop 1 and loop 2. Two loops. So two loops, then give the current direction. So in general, just go through like a source direction. So source current direction you can consider means you will get the positive answer. Okay. Now here second step is you need to give the current directions. So like current means mesh direction, loop direction. So this is my loop direction. Okay, using source. Then apply the Kirchhoff's voltage law. For that I require the voltage drops. So voltage drop means, so here what is the voltage drop in this branch, and in this branch what is the voltage drop, for this branch what is the voltage drop. Okay, coming to voltage drops guys, here we have the voltage. So maximum we have the voltage source means just give the voltage value, which value we have. Okay, coming to resistors or inductor or capacitor. So for the AC we have the inductor, capacitor also. For DC we have only resistor. When you have the resistor, single resistor, then how many currents we have? For voltage drop for this resistor is depending upon your current. So how many currents we have for this resistor? For this circuit, for R1 I have only one current. So only one current means no need to worry about it. So which current we have? That current into your resistor. So here I have I1 current. So I1 current into resistor. Coming to R3, I have two currents. So that R3 connected between two loops. So loop 1 as well as loop 2. So I have the two currents. So for these two currents, check the directions. So this I1 direction is downwards, I2 direction also downwards. If suppose both directions are reverse, then what is the answer? Here both directions same means, so I1 is incoming and I2 also incoming. So we have the formula I1 plus I2. That is your total current. Suppose both are reverse. So both are reverse means again we have one more small logic. So we are writing the equation for loop 1 means that is I1 minus I2. That is the current for loop 1. If suppose we are writing the loop 2 equation means that is I2 minus I1. So I1 for I1 current loop, I want to write the equation means I1 minus I2. I want to write the equation for loop 2 means I2 minus I1. Okay, and into your resistor is as it is. Okay, so now check it now. Your equations for loop 1 we have V1. So V1 voltage drop we have. So completed this voltage drop. Coming to this voltage drop, I1 into I1 into R1. Coming to this voltage drop, when you have the loop 1, this voltage drop is I1 plus I2 into R3. I1 plus I2 into R3 equal to 0. Okay. Coming to loop 2, again I have the voltage drop, this voltage drop, and here I have I2 into R2, and R3, again I have two currents. So I1 plus I2. So both are same direction. If suppose both are reverse direction, means we need to get like I2 minus I1. I2 minus I1. So why I2 minus I1 means I am writing the loop 2 equation. So I need to depend on the loop 2 current. So loop 2 current is reverse with I1 current. So I1 current is reverse to loop 2 current. So I have the I2 minus I1. But here both are same direction. So I1 plus I2. Then two equation, two unknown values, will get the I1 and I2 values. I1 and I2 values. Okay. So if I know the I1 and I2 values, I can find out the unknown values. So suppose here I1 current. So what is the current at R3 resistor? So R3 is equal to, so both are same direction at R3 resistor. So we have I1 plus I2. Okay. Now this is your R3 current. Suppose I want voltage drop here. I want voltage drop here, R1. So VR1 is equal to I1 into R1. So I know the I1 value, I know the R1 value, will get the IR1 value. Okay. So this is about like a mesh analysis. Coming to super mesh analysis, same logic, but here only one difference is when we have the ideal current source. So this is my ideal current source between two loops. So between two loops, if I have the ideal current source, it's very simple. So why means actually generally mesh analysis means we can find out the loop currents. But this ideal current source between two loops, we have the ideal current source. So for this, I will find out the super mesh equation. So we have the mesh equation means loop equation, voltage drops for each places. But coming to, if you observe the circuit here, so this ideal current source, so I can find out the voltage drop here, but I can't get the voltage drop here. So for this, so ideal current source we have. So for this ideal current source, we need to go for the super loop equation. So super loop. So I need to remove the current source, which current source ideally, remove the current source and get total. So two loops, combine one loop and get the loop equation. Same, Kirchhoff's voltage law only, not another laws. So using Kirchhoff's voltage law, find out the equation. And which current we removed. For this current also with the equation. We will check it now. So coming to this circuit, I have one current source. That is ideally between two loops. I have the ideal current source. Now for this current source, this is one point. Consider this is the one point. So here incoming currents and here I2 also incoming and I1 is outgoing. So before going to this, first we need to know the number of loops and current directions. Then check the voltage drop. Here I have the voltage drop. Here I have the voltage drop. And here I have the voltage drop. Here I have the voltage drop. But here I don't have voltage drop. For that I need to go to the super loop. Now at this point I have IA, I1 and this I2 and here I. Now IA, I1 and I2 both are incoming. So I1 plus I2 is equal to your I. That is the equation for this ideal current source. For this ideal current source, this is the equation. And coming to super loop, so remove the ideal current source. This current source is not there. Then go for total. Total is your loop now. And what is the loop direction? Your wish. So you can take any direction. There is no condition again. For loop direction, there is no condition. You can use any direction. But the direction is depending upon the values, plus or minus. Here, so I take like loop 1 direction. So loop 1 direction and super loop direction both are same now. So here minus V1 is as it is. And here also I1 value as it is. Coming to here, IR2. So I2 current and super loop current both are reverse. So this is your super loop direction and this is your loop 2 direction. So both are reverse. Reverse means we will get like minus IR2 value. Here check the equation. Here minus IR2 value. And as V2 have the minus value, but we will get a plus value. So this is Small difference. So when you have the direction, so you can take any direction. There is no condition. Which direction we have. So depending upon direction, we'll get the positive value or negative value. Okay. And this is about the Supermesh analysis. Coming to nodal analysis, same procedure. In mesh analysis, we have the loops. Coming to nodal analysis, we have the nodes. Nodes. We need to mention the node. So their node point. So which node, how many nodes we have? For particular nodes, I need to find out the voltage drops. So in particular node, I need to find out the voltages. So we have the steps. Again, same steps. Identify the number of nodes and node voltages and Kirchhoff's. And it uses Kirchhoff's current law. So particular node, incoming currents are equal to outgoing currents. So using that law, I find out the equations. Then again, on voltage, unknown values, voltage values, and unknown which current value, power value, which value we can find out. Okay. Now coming to small circuit here. So for this circuit, my nodes is only one node I have, that is V1 node. If you want to consider, these are the one node, so you can consider, no problem. But the values we know, that is VA value. Again, no need to find out that value. So in between this node, what is the VA value? Already we have that VA value. So that's why I'm having like V1 here. For this circuit, I have a V1 here, and here one more circuit I have, one more value, that is reference node. That value is reference node. That node is reference node. That reference node voltage is 0. So any circuit, I will compare with another point. So that point is ground point. You can say like ground. So that ground value is 0. Okay. So in particular circuit, I have V1 value and VR value. VR is 0. So between, so V1 and VR, I need to find out the how many branches we have. So in this circuit, this small circuit, guys, for this circuit we have 1, 2, 3 branches. So 3 branches means I require 3 currents. So using Kirchhoff's current law, so we have 3 at this point, particular point, I have the 3 currents. Then write the I1, suppose is the I1 direction, I2 direction, I3 direction. So I1 is incoming, I2 is outgoing, and I3 is incoming. So write that value using Kirchhoff's current law. I1 plus I3 minus I2 equal to 0. So I2 is outgoing. So I1 and I3 is incoming. So use that logic and find out the equation. But what is the current value here? What is the current value here? What is the current value here? So in coming to mesh analysis, we have the voltage drop. So I need to find the voltage values. Coming to nodal analysis, I require current values. For current values, that is value is V by R. General I equal to V by R. So what is the voltage drop? So this voltage drop is very, very important for each branch. So for this branch, we have the voltage already. We have the VA value, and for this node, I mentioned like V1 value. So between this branch, what is the voltage? So that is, check the direction. Direction is VA to, so here direction also depending upon you only. Okay. So direction VA to V1. So value is VA minus V1. If suppose your direction is reverse. So your value is V1 minus VA. That is your voltage. And by resistor is your R1. So VA minus V1 by R1. That is your voltage drop. Same thing here. The current direction downwards. So that is a VA, V1 to VR. So V1 minus VR by your R3. Coming to here, the direction also here VB to V1. So VB minus V1 by R2. Guys, remember. So which direction we have? So direction is suppose this direction. So VA1 minus VB by R2. So depending upon direction, we'll get the different value. Okay. So same thing, V1 value, V2 value, and V3 value substitute here. So then we have only one equation, that is V1 you can find out. If you have 2 nodes, you can get the 2 equation, you can find out the V1, V2 values. Okay. And unknown values. Suppose I want current value, using substitute VA and V1 value, get I1 value. Substitute V1 and VR value, get R3 value, that is I2 value. Okay, so this is about the nodal analysis. Same thing we have the supernode analysis. So in supermesh, when you have the ideal current source, then we are moving to supermesh analysis. Here also, when you have the ideal voltage source, then I'll go to the node analysis. So where you have this ideal voltage source, between two nodes, I have one ideal voltage source. So I will go for the supernode analysis. Again, same procedure. Mention the nodes. So I have the 1, 2, 3 nodes for this circuit. Okay, V1, V2, V3. V3 means VR. VR is 0. and currents. So I1, I2, I3 and I4. For this branch, your I1 direction, so VA to V1, VA minus V1 by R, and here V1 to VR, so V1 minus VR by R2, and here V2 to VR, V2 minus VR by R3, and here V2 to, so like VB to VR, so VB minus V2 by R4. So we can't say what is the current here. We have a voltage. Now for this we have like super node. So combine two nodes. Now we don't have voltage source here. Combine two nodes and get the node equation there. But for this ideal voltage source, I have one equation. For this ideal voltage source, I have one equation. What is the equation means? So between two nodes, just observe clearly. This is also very, very important. So between two nodes, I have one voltage source. Just check the direction. So negative to positive are the current direction. Negative to positive my current direction, and VA and V2. So which manner we have? VA minus V1. So VA to V1 I have. So VA minus V1. Here I have voltage is voltage I have V1 minus V1 and V2 I have voltage. So negative, positive, and here VC and here V1 and here V2. So I taken like direction your source direction. So source direction I taken. So the direction is V2 to V1. So V2 minus V1. V2 minus V1 equal to your minus VC. Otherwise, you can write V2 plus VC minus V1. So V2 is current is coming from V2 and again coming from VC. So V2 plus VC minus V1 equal to 0. Okay. So your wish that is. So any direction you can take. If suppose your direction, this is your direction. So V1, but your source, which source this is? Ideal source. The direction is general, positive to negative. So we have minus VC, minus V2 equal to 0. So we'll get like V2 minus V1 equal to minus VC. So same thing which you have within any direction. And coming to supernode, how many currents we have? How many branches we have? 1, 2, 3, 4 branches. So 4 branches, I1 is incoming, I2 outgoing, I3 outgoing, and I4 is incoming. So I1 plus, I4 plus, and I2 and I3 minus. So we have the values. So this equation number 2, this is equation number 1. So 1 and 2, two unknown values, find out the V and V2 value and get the answers. Which current we want, or which voltage we want, or which power we want. Okay. And coming to last one more topic, that is inspection method. It's a very, very simple and very, very important also. So when we have the like n number of equations. So here 3 equations I have. For 3 equations, I want to find out the 3 unknown values. So when you have the source mesh analysis or nodal analysis or any supermesh supernode, then we have the equations. So from that equation, I find out the currents. So using calculation, it's very simple. But when we have one method, that is inspection method, then we need to use the Cramer's rule. So 3 equation, we need to convert into matrix. From matrix to, you can use the Cramer's rule and get the answer. Okay, that Cramer's rule is delta 1 by, so del of delta 1 by delta, and del of delta 2 by delta, and del of delta 3 by del of delta. So what is your delta value means? This is your main matrix. So equation to matrix, we know that. So these are the x values, y values, z values. That is x, y, z values equal to this value. So I need to find out the x, y, z. In between x, y, z, I have like currents. Suppose mesh equation means I1, I2, I3. Voltage means V1, V2, V3. Okay. Same I1, I2, I3. Suppose I want I1 value. So del of delta 1 by del of delta. That is your I1 value. So you will get the delta values. That is main matrix is your delta. Delta 1 value means, so delta 1 means remove the I1 values. Here x values. Remove the x values. Replace with your equal values. Remove the I2 values. Replace with your x2 values. Remove the I3 values. Replace with equal values. Those are the delta 3, delta 2, delta 1 values. Again, it's very simple. Okay. I have small problem here. So two equation. From two equations, I have two loops. I have 2 equations. Then go for the like a matrix form. So I1 values and I2 values, I1 values, I2 values, and these are equal values. Now I want delta means main matrix, and delta 1 means remove the I1 value and replace with your equal value. Remove the I2 value and replace with your equal values. So these are the del. Then Cramer's rule, cross multiply. Then we'll get like del of delta 1, del of delta 2. Then I1 equal to del of delta 1 by your del of delta. Del of delta 2 by del of delta. So these are the inspection method. So any analysis, any circuit theorems or anything. So you want to find out the any unknown values. So using these methods. So current division rule, voltage division rule, source transformation, star to delta, delta to star, Kirchhoff's laws, and series parallel, as well as mesh, nodal, supermesh, supernode analysis, as well as inspection method. If you know these methods, it's very simple to find out. Okay, and if you have any queries on this methods analysis, just comment in comment box. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.